Hello students, how are you doing? I hope you are doing well. Okay, so this is a good moment to share with you the first lecture on e-learning. This is Physics 101, which is called Engineering Physics. The topic of today, it is kinematics in one direction or rectilinear motion. Okay, so there are some terms that are going to be used to describe the object in motion. The first term is called reference. So you cannot say that the object is moving or not without having a reference. A reference point is used to find or to describe the location of an object. In physics, a reference point is often the origin of system of axes. For example, here on this figure, you cannot mention the direction of the moving body if you don't have the reference point 0. Here we have two directions, positive direction, the negative direction, according to the reference 0. The second term, it is position. So the position is defined as the location of the object relative to the reference point. And the position is measured in a meter. The third definition is displacement. The displacement is the change from one position to the other position. It means that the object is moving. So the displacement is written as a change of area when the direction is not well defined, and it is equal to the final position of the object minus initial position. Displacement is a vector quantity. The distance is a scalar quantity which represents the interval between 2 points. The fourth definition or term, it is a velocity. The velocity is a measure of how fast a displacement is made. The velocity is also a vector quantity. It can be average or instantaneous. The average velocity, it is when you have the different velocities from different positions, and then you need to do the mathematical average to get one velocity which can represent the whole journey. Whereas the instantaneous velocity, it is the velocity at one point. So on the formula, the average is calculated as the displacement over the time interval or the change of time. And the instantaneous velocity is the limit of the average velocity when the change of time is tending to be 0. As you know, the average is equal to the change of r over change of t. When you replace it in the formula for the limit, you get the definition of derivative So the instantaneous velocity is the derivative of displacement with respect to time. The last term to be used to describe object in motion is the acceleration. Acceleration is defined as the rate of change of velocity per unit time. The acceleration is also a vector, and it can be also average or instantaneous. The average acceleration, it is the mathematical average of different accelerations on different positions. Whereas the instantaneous acceleration, it is acceleration for the specific position of the object. For formula, the average acceleration is calculated as the change of velocity divided by change of time. The instantaneous acceleration, it is the limit of the average acceleration when the change of time is tending to be zero, which gives us the derivative of the velocity. So acceleration or instantaneous acceleration is the derivative of velocity with respect to time. This topic of rectilinear motion belongs to the part of physics called mechanics. Mechanics is the part of physics which deals with the behavior of bodies in motion and bodies at rest. So kinematics is one of the part of dynamics that consists of describing the motion of an object without considering the causes. Here, the motion can be in 1, 2, or 3 dimensions. The motion in 1 dimension, it is called rectilinear motion, or kinematics in 1 dimension. It consists of describing the motion of an object along a straight line. The straight line can be horizontal or vertical. If the straight line is horizontal, we have horizontal motion, and it is a motion along x-axis. As the motion of an object is described with reference to its corresponding velocity or speed, there are 2 types of motions: uniform rectilinear motion and uniformly varied rectilinear motion. For uniform rectilinear motion, the velocity is uniform or constant, and the motion is along a straight line. By using the previous terms, we can describe this kind of motion. Velocity is a constant. It means that the initial, final, and the average velocities are the same. Now, as the velocity is a constant, now the acceleration will be 0, which means for uniform rectilinear motion, there's no acceleration, because final velocity minus initial velocity will give you 0 because they are equal. The formula for displacement or distance, it is equal to the average velocity multiplied by time, where the average velocity is equal to the final velocity plus initial velocity divided by 2. The second type of motion is uniformly varied rectilinear motion. is defined as the motion along a straight line with constant acceleration. Constant acceleration means that the velocity is changing, but it's changing uniformly. Here we have two types of motions. We have accelerated motion and we have decelerated motion. For accelerated motion, the acceleration is positive because final velocity is greater than initial velocity. And v minus u will give you a positive value. The value of acceleration is equal to the final velocity minus initial velocity divided by t. From this definition, we can get the formula for the velocity. Instantaneous velocity is equal to the acceleration of the body multiplied by time used plus initial velocity. And the third formula is the formula for displacement, x, which is equal to the average velocity multiplied by time. Here we have two formulas for displacement or distance. X is equal to average velocity multiplied by time, and we replace average velocity by its value, v plus u divided by 2. Also, by replacing the value of v in this formula, which is equal to a multiplied by t plus u, here, we are going to get 1 over 2 at squared plus ut. The second formula for distance, now we are going to replace the value of average velocity and the value of time. The time, from the definition of acceleration, it will be final velocity minus initial velocity divided by acceleration. So this v plus u multiplied by v minus u, it is equal to v squared minus u squared divided by 2a. Okay, now in summary, we are going to have 3 important equations of motion. The first equation, it is the equation of the velocity, which helps us to get the value of instantaneous velocity. It is instantaneous because it depends on time t. V is equal to initial velocity plus acceleration multiplied by time. The second equation of motion, x is equal to initial velocity multiplied by time plus acceleration multiplied by t power 2 divided by 2. And the third equation of motion, x is equal to v squared minus u squared divided by 2a. Okay, this was description of moving body in the horizontal direction. Now let's have a look on the vertical direction. The vertical motion, it is defined as the motion along a vertical straight line, y-axis, against the gravitational pull. For free fall, Galileo postulated that at a given location of the Earth, and in the absence of air or other resistance, all objects fall with the same constant acceleration. And this acceleration is called acceleration due to gravity, which has a value of 9.81 meters per second squared. Thus, vertical motion is a particular case of uniformly valued rectilinear motion because g has a fixed value, and the 3 equations of motion are still valid. Here we have 2 types of motion. ascending motion and descending motion. For ascending motion, it is when the object is thrown upward. Here, the object will move in opposition to the gravity, which means the acceleration will be taken as negative. Now, the first equation of motion will be v is equal to minus gt plus initial velocity. Now, when the object reaches at its maximum, at the maximum point, its final velocity will be equal to 0. And from that, you can get the value of the time used to reach the highest point, T max, which is equal to u, or initial velocity divided by acceleration due to gravity. The second equation of motion, y will be equal to minus 1/2 g time squared plus initial velocity multiplied by t. And the third equation of motion will be initial velocity power 2 minus final velocity power 2 divided by 2g. If the object reaches the maximum point, then the maximum distance moved by the body will be equal to initial velocity power 2 divided by 2g. Now, for descending motion, here the object is moving in the same direction of the gravity. Now, g is taken as a positive here. The first equation of motion would be v equal to g multiplied by time, because for descending motion, the initial velocity is not required. It is equal to 0. And the second equation of motion, y, will be 1/2 g t squared. And this will help us to get the time used by the body to reach the ground, which is equal to the square root of 2y divided by g. Here, y is the moved distance from the initial point to the ground. And the third equation of motion, y is equal to initial velocity power 2 plus final velocity power 2 divided by 2g. This will help us to get the velocity of the object when it reaches the ground. This velocity will be square root of 2g multiplied by distance. At the absence of air resistance, the time to go up is equal to the time to go down. It means upward time is equal to downward time, because the rate of change of velocity is the same. G is the constant. Thus, the time of flight, or the total time, it will be the double of one of the time t up or t down. Here we have an example. Try to do it on a paper. A pitcher tosses a baseball up along a y-axis with an initial speed of 12 meters per second. How long does the ball take to reach its maximum height? 2. What is the ball's maximum height above its raised point? Question number 3. Find the time of flight, or the total time. Try to do it. Take a paper and then try to do it. Okay, let's do it together. The time to reach the maximum point, that was the first question, question number 1. The time to reach the maximum point, Tmax, it is equal to initial velocity divided by acceleration due to gravity. Okay, now Tmax is equal to 12 meter per second Tmax is equal to 12 meter per second divided by divided by 10 meter per second squared. Okay, this is equal to 1.2 seconds. Fine. I think everyone has got this answer. The question number 2, what is the Ymax? Ymax here is equal to initial velocity power 2, initial velocity power 2 divided by 2g. This is equal to 12 meter per second power 2 divided by 20. Which is equal to 7.2 meter. Okay. Question number 3. It is time of flight or the total time. Time to go up plus time to go down. Time of flight is equal to double T max. Okay, this is equal to 2 multiplied by 1.2 seconds, which is equal to 2.4 seconds. Okay, so that was the example, and I think all of you have got these answers. So now let's continue. Let's continue now. with the description of object's motion by using graph. Here we have three types of graphs. We have displacement time graph, velocity time graph, and acceleration time graph. The first graph, displacement time graph. Here we have the horizontal straight line. Horizontal straight line means that the position doesn't change. If the position doesn't change, means that there is no movement. The second one, we have the slope. We have the straight line, which is not horizontal, which is oblique. And here, the motion starts from 0. The third one, the motion starts from position, which is not 0 position. And the last type of graph, it is, we have no straight line, we have a curve, which means that the rate of change of displacement is not constant. And the rate of change of displacement, remember, it is the velocity. So for the first case, second case, and the third case, the velocity is constant because we have the straight line. But for the last case, the velocity is not constant because we have a curve. You can see it on the vertical axis. It means that the positions are changing, but not at the same rate. Now, the slope, when we try to calculate the slope of this graph, the slope is defined as the vertical change divided by horizontal change. For our case, the vertical change is distance and the horizontal change is time, which means that the slope of the displacement time graph determines the velocity of the moving body. For the first case, the velocity is 0 because there is no slope. For the other cases, the velocity, second case and the third case, the velocity is constant. And the last case, the velocity is not constant. Okay, now when you are given a graph like this, you can calculate the velocity of the object by using the slope, by calculating the slope of that graph. The second type of graph, it is velocity time graph. Here we have also three types of graphs. We have the horizontal line, horizontal straight line, which means that the velocity is not changing, because here we have on a vertical axis, we have velocity. This velocity, it is not changing from 0 second to the last second. And also there's no slope. For the second case, there is a slope, which is a straight line from the initial point. And here you have also the slope. And the slope here, it represents the acceleration, because slope, as you remember, it is the vertical change divided by horizontal change. Vertically, we have the velocity, horizontally, we have time, and the change of time divided by change of velocity, sorry, divided by change of time give you the acceleration. For the last one, we have also the slope, but which is downward oriented. This means that the velocity change, but it changes it is decreasing, not increasing. It is decreasing. Decreasing means we have decelerated motion. Whereas the previous case, the velocity is increasing with time. If the velocity is increasing with time, now the rate of change is positive. So here we have accelerated motion, here we have decelerated motion, whereas for the first case, we have uniform rectilinear motion where there is no acceleration. So as I said, the slope of velocity time graph represents the acceleration of a moving body. You can also calculate the area under the velocity time graph. The area under the velocity time graph represent the distance moved by the body. Here we have different graphs. The first one, we have a figure which is rectangle. The second case, we have a triangle. The third case, we have a trapezoid. The last one, we have the mixed complex shape, which has different shapes of figures. And when you calculate the area of rectangle, it is the base multiplied by height. And here, the base is time, and the height, it is velocity. So velocity times t, you get the distance. For triangle, area is 1/2 base multiplied by height. Base is the time, and the height, it is the velocity. You have also the distance. The trapezoid, area for trapezoid, it is 1/2 times the base b multiplied by h plus h prime. You know that the area of trapezium, it is small base plus a big base multiplied by height divided by 2. Here, the height is b. The big base of our trapezium, it is this side, which is h prime. The small base, it is the other side, which is h. For the complex shape, you calculate the shape of area 1, you calculate the area 1, area 2, area 3, and area 4, and then you do the sum. Okay. The third type of graph, it is acceleration time graph. Here we will have only horizontal straight line because we have only 2 types of motions: uniformly varied accelerated or uniformly varied rectilinear motion and uniform rectilinear motion, which means the acceleration is always constant. If the acceleration is constant, we will not have a slope. That's why here we have an horizontal straight line. So here we can calculate now the area under the acceleration time graph, which represents the velocity of the body. You have exercises which you are going to do at your home as an assignment. Size number 1, size number 2, size number 3, 4, and 5. Now, this is the end of lecture 1. The lecture 2 will be kinematics in 2 dimensions. And the next slide are the tips which will help you to understand physics and therefore to succeed. We have effective use of tutorials. Here we have two effective use. We have also advice from me as facilitator. If your career choice is technology, science, engineering, or similar field, there is no more important beginning course than physics. So, to study physics differently than you would approach the liberal arts, applications and problem solving require different skills and strategies. So you have to plan your course sequences carefully. You must have the necessary preparation for physics and do not get behind in physics. The topics are sequential and each successive step requires a mastery of the preceding steps. Cramming is not possible. And here there is a say that I know the material, but I just can't perform on tests. So the major way to deal with such fears is through practice and adequate preparations. It's like shooting free throws when a basketball game is on the line. You must practice for shots until they become automatic during times of high pressure. Thank you very much. See you next time. Bye-bye.